Rally cars are the most technologically advanced vehicles on the planet. Their ability to tackle tough terrains of gravel, sand, and even mud with great agility, speed, stability, and safety is unmatched. In this video, we are going to cover the basics of how a rally car works. Starting from the exterior, rally cars are adapted from normal cars on the road. For instance, Toyota's GR Yaris is based off of the Yaris platform. Interestingly, this similarity stops with the shell as all the other internals are swapped out with custom performance parts. Even so, the exterior is heavily modified for aerodynamics as per the WRC rules. The car's body panels snap together and can be easily bolted onto the chassis. Materials range from carbon fiber to aluminum. The chassis is made up of a space frame designed to provide maximum protection for the driver and the co-driver. Aerodynamic features include side skirts and a pronounced rear spoiler for downforce and stability, as well as air ducts for cooling various internal components. On the front, the cars have a splitter meant for creating downforce. On either side, they are fitted with dive planes that not only provide aggressive looks but also channel air along the side panels. Note that in the new cars, there's just a single dive plane that attaches to the front bumper from the side. The wider wheel arches, side vents, and skirts help direct air from front of the car, while also directing air away from the tires to reduce drag. The new regulations discourage use of rear diffusers. Diffusers reduce turbulence caused by air flowing under the car by creating more downforce and traction on the rear wheels. As air flows over the car, the spoiler directs it accordingly to generate rear downforce. The WRC regulations dictate the shape and the size of the spoiler. In terms of safety, under the external frame is a rigid roll cage that creates a safety cell to protect the driver and his co-driver. Brake calipers. In a rally car, the braking system is a critical component for controlling speed during high-speed maneuvers. On tarmac surfaces, the engineers typically apply large brake discs measuring 366 mm by 24 mm with 6 grooves. These are mounted to aerospace-grade aluminum mounting belts at the front of the car. At the rear, you'll find 3 or 5 mm discs. These substantial discs are wrapped by 8-port calipers with titanium pistons at the front and 4-port variants at the rear. The combination of powerful brakes and precise modulation allows rally drivers to decelerate rapidly, navigate hairpin turns, and maintain control even in challenging conditions. Transmission and axle. The transmissions of rally cars feature a 4-wheel drive configuration with 5-speed gearboxes and a mechanical shift. Notably, in the new rally car, the active central differential has been removed. The suspension has been streamlined, allowing a reduced amount of damper travel. The transmission system plays a crucial role in transferring power from the engine to the wheels. Rally 1 cars use a sequential gearbox with 5 speeds. Unlike normal manual gearboxes, where you can shift gears in any order, a sequential gearbox requires sequential shifts, which is up or down. The driver operates the gear lever to select the next gear, which engages automatically. The cars have both front and rear differentials which distribute power between the front and rear wheels, allowing for optimal traction. The mechanical differentials adjust torque distribution based on wheel slip during acceleration and cornering. With the introduction of the hybrid system, the driver has to manage the ICE and electric power to avoid depleting the battery. If the battery runs low, they need to regenerate energy during road sections. Safety systems. Safety systems in rally cars are robust and meticulously designed. Aluminum tubes connect the rear bumper to the rear clip, forming a framework capable of absorbing strong impact. The roll cage serves as the driver's main protection. It is a robust structure made of tubular steel that surrounds the cockpit. It provides structural integrity and prevents the cabin from collapsing during impacts. On the side, There are heavy steel anti-intrusion panels that protects the drivers from objects that might penetrate the vehicle from either side during a crash. The doors, front and rear bumpers are lined with thick, injection-molded foam blocks to improve the car's ability to absorb impacts from all directions during accidents. The redesigned roof section can absorb up to 115% more energy compared to the previous design. The cars come with independent front and rear suspension, allowing each wheel to move individually depending on the terrain. The control arms are both connected directly to the chassis. The coil-over style adjustable shocks have dampers located inside the springs.